Welcome everyone live here to the Exacode headquarter, here live on our channel. Oops, we did it again. We wrote another Linux kernel driver, not only for the P3 SG Octane, but this time latest and greatest state-of-the-art DDR5 SPD-Hub, temperature and NVRAM SPD eeprom flash data. You might ask why. So why did I again waste my time for this stuff? Because mostly I wanted to know how hot my memory is, right? Normally you would think the most normal thing of the world that you buy hardware even on launch day for the latest and greatest overpriced stuff, and everything would work on a proper professional operating system like Linux and not on some garish startup there out of Seattle with their quick and dirty operating system. And of course it didn't. And I'm really disappointed that the big vendors like Intel, AMD, but even Gigabyte, Asus and stuff don't get out of their cubicle and send some patches. Because so I've done it already last night, yesterday evening and last night. It took way longer, so it's already working. This driver here is from me, SPD 5118, and also so it took way longer than I wanted. I was actually yesterday thinking, should I live stream that, but it would have been an hour-long boring ordeal. But as usual, share, like, subscribe and comment and stuff of also previous videos. I can show you the code here. That is here 2023 inspired by, oh wait a second, I mistyped it here. This is not inspired by SP, this is my driver. What was the other? EE1 Echo. What was the other thing? E1 E1 hour something C. Was it not? Oh, come on, drivers H1. What even was the other driver? MISC eeprom. Wait, no, this was HC H1. Too many drivers. Oh no, this was the other. Wait a second. MISC. Always when I got distracted. And driver names. What should I say? Of course, it's in MISC and stuff. That was EEE 104. I think this one. Nothing like proofreading your stuff. Actually, I would say if we. Okay, alphabetically doesn't matter. So what is it about, right? So previously there were other standards, and so previously the the DDR4 memory, previous video, DDR4 of course also had SPD probably since DDR for 15 years or so. There's a tiny little integrated circuit, tiny little, and also this is top secret, I need to scroll fast. You're not supposed to see this, so some tiny little integrated circuit for the memory configurations, all the primary, secondary timings, and also manufacturing strings such as serial number and product and stuff like CMK64. So this is my driver, right? Just some debugging stuff. And so previously, so SPD, that is serial presence detect, with all this information. Is that also top secret? You're not supposed to see here. Copyrighted material, can't show that for long. You need to Google it yourself. Also, actually took me also like not only, there's not a driver, and it took me hours of like, and also registering on some websites and some shady forums and stuff to actually find this, right? So recurring theme, even 25-year veteran Linux kernel developer needs 2 hours just to gather all the bloody information, when at the end of the day it's not that much code. Now I also need to polish it. 296 lines of code and you have a freaking working kernel driver. And that's actually not that bad, and that even includes some for loop of testing. So that is all that's needed, and that is also shame on AMD, Intel, Gigabyte, Asus, MSI, what all the other? Server Micro, IBM, Oracle, and so on. Basically everyone, and Micron and Hynix and Samsung and stuff. So should have been long in the kernel. That is not that super top secret. And so yeah, leave in the comments below, so I can go through here. And so this is doing two things, also that you learn on something new. In DDR5, the new thing, I should have, I have new, actually, here is a package. In DDR5, illustration purposes, not a paid advertisement. So new is, so this is entirely new, entirely new. So now the SPD has an integrated, there is an SPD-Hub. This is based on this JEDEC standard 5118. And now we also have with DDR5, we also have power management, integrated circuits, PMICs, there for on-module higher efficiency voltage generation. And also usually those hubs should, maybe all do, I don't have that many, if you're a memory vendor, Intel, AMD or motherboard manufacturer and want to support your, improve your Linux support stuff, happy to receive some samples, right? Samples welcome. I don't have too many, can't buy each of those. So what this also does, so now it's integrated, right? Previously these were two things. Previously we had EE1004, that was the SPD interface. So previously these were two separate integrated circuits. And the JC also a JEDEC standard for optional temperature modules and very few, like only high-end DDR4 memory modules included temperature sensor. I only have one of all the various stock in the company. Previous video, whatever that was, also maybe G-Scale also. And so that is a different module. So what changes now? So this is mostly changed. So all this stuff is new. I had to find some forbidden documents and type in here some magic values. And so basically, all in all, it is not that difficult. The biggest thing was like basically my code would have been working in the first hour. There's the usual recurring theme here. Like basically inspiring from EE1004 and JC42 drivers. I obviously don't want to like all this like skeleton of module and I2C stuff. So that is of course still connected with I2C. Also now it is I3C for optional higher performance and some other features. So that is optional higher bit rate and parity checking. And other fine details. And so what is also new, so it's not yet a complete driver, that's also like, so basically on this I burned already a couple of hours, and thankfully I didn't live stream it because I would have looked like a fool. Basically I didn't even crash my workstation once, but initially I didn't get the right data out of here, right? This is why also I still have like all this print case stuff here, like I don't know what's going on. Reading the standards, debugging around there, what's happening on the I2C stuff in the Linux kernel. Wasted way too many hours, and I probably wasted 2 hours just to find out that it could have worked from the beginning if it were not for the default page, because there are multiple pages. You have there some window of 256 bytes here of all the stuff that's defined in the SPD, for example, the serial presence detect, flash memory there, non-volatile memory. And so I was basically reading, like basically how the BIOS is reading this, of course, to get an idea, what memory is in there, is it compatible, how to start training it, what timings to start using and so on, all the XMP and expo data. And the BIOS left it in whatever the BIOS used last. And so I was getting there values that I didn't expect because it was simply in some other access mode. And so basically for this one line here of I2C SM bus write, that's like, yeah, one of the most expensive lines again. And that is the stuff if you're not doing this regularly, which is also kind of why the companies could do that themselves and not like some external people who nobody pays for. Also people at Asus and Gigabyte probably also would have spent 2 hours or more to get it to work. Anyway, here's some mostly debugging. So the question is also what I want to do, also like some print K of like what do I get there, because initially this was some random stuff. And then recurrently with this HWMon interface on Linux kernel, I currently have here some SPD5118 read here for this temp input, and then reads this here through some rec map. What this rec map does, maybe we don't really need this rec map. What it does is a generic facility of the Linux kernel for register maps. So they are cached and not reread, so you have your functions to return which are readable, writable, and volatile. Volatile, for example, the temperature register. Currently I inspired that from the JC42 driver. That supports some additional stuff, which are like min, max, whatever alarm stuff, which is more work to implement and I don't need. So yeah, so basically for one register we wouldn't really need a register map, but maybe we leave it in there. The question is also, what do the Linux kernel developer mailing list people and subsystem maintainers do? Like, do they want that? Will they notice, hey, you have only one register, rework it without this rec map, whatever. We need to convert this here from, as per the standards that I'm not allowed to show you. There are some reserved bits at the least and most significant bits. So similar to the other driver, we sign extend that here differently. We shift this to reserved bits away, sign extended from the 11th remaining bit there, and then that has 2 fractional bits. So multiplying that to millivolt for the HWMon driver and dividing it by 4 for the 2 fractional bits there defined by the hardware. And that's kind of basically most of it. Additionally, so that's basically, that is now all I need, except here's of course some debugging going on. So basically all of this stuff here, for example, is, of course, all of this print case stuff. And this one is all just fiddling around, debugging, waiting, like tweaking values, guru meditating the documentation, and nothing like live reloading. And then other pro tip, of course, either remote and then async or whatever, and of course, thanks to modular loadable kernel modules, we can reload in the fly. Let's see how many. Okay, we have still probe, and here are my 2 sensors as M-bus adapter. There's another thing that so by default on this gigabyte Aorus master, recurring annoyance, the ACPI tables define this as some devices. And so I had to, first of all, I wondered where was my SM bus adapter. I previously, some months ago already, fiddled around with it. Only yesterday for this, I finally got this to work, realizing it's just because of the ACPI resource conflicts. Nonsense booting with ACPI resource, whatever, equals lex. Fixes that, not the nicest thing. Recurring theme, ACPI and PC BIOS stuff is annoying random garbage. So yeah, you need to have this working, and then similar to the old addresses, so basically similar to previous, like probably all DDR SPDs, the addresses remain 50 to 58 or more, whatever, hex on the I2C bus. And here's the 2 temperatures. I believe they are, they make sense. If I'm totally idle, then it is, and that was the point, right? Why did I do this exercise? And first of all, I of course like my hardware fully supported by my operating system. And second of all, I wanted to know, because I overvolt and underclock this, right? Previous videos there on my Moment channel. So these are 5600. I overclock them in the meantime. Initially it didn't work, but in the meantime with the more stable BIOS, previous video, right? I made multiple videos how unstable this AGESA or Gigabyte BIOS was. But in the meantime, after all my YouTube videos, and Gigabyte apparently was listening here to my expert opinion, not only 5800, but in the meantime, totally to my surprise, overclocking this to 6000 mega transfers. as a otherwise nominal 5600, and I overvolt this, right? So this is rated 1.25 or so volts. This would be the next thing, right? So theoretically, what would be the next thing? Decoding all of this JEDEC stuff. Oops, somehow I believe I clicked this wrong now. Darn. Recently closed on thing like on that. So the other voltage. Right. So we could decode this. So theoretically, the problem is I have no funding, right? This is already more time than I should have spent on that. Basically all-nighter here for my operating system. But that would be the thing. So normally you could decode DIMMs also, I believe. So this would still need to be implemented. I could implement this next. We could even do this live after this video. Probably makes sense to cut this in two to optimize views and stuff. But that is basically what Linux kernel developers do, right? And I believe this decode, that's also the sad thing, that is, I believe this is unmaintained. I2C tools, I believe, unfortunately they are unmaintained, and I'm not the greatest. Wait, here is, or are they not unmaintained for? Oh no, there is 20. But where was I yesterday? I believe I was in some GitHub where basically someone, was it not that? Whatever. It doesn't look, I mean, it's a little bit oldish, not the most. But this is this kind of stuff where you wonder, like, why is this stuff not more maintained? Also, maybe most developers currently have here the issue, like myself, of nobody's funding this fun stuff, right? Share, like, subscribe, Patreon, GitHub, GoFundMe, YouTube membership, and all this stuff. Because again, so for this 400 lines of code, and that's also the thing, right? So how do you usually work? I personally, I mean, I don't write this stuff from scratch, right? So I inspire the skeleton stuff from the next best driver, which is why I put here inspired by those. Although from this, I currently don't have code in there, but I will have to copy some. I mean, obviously, I know I'm not retyping this, right? Either you ask your AI copilot, or you just open your next best visual editor and copy this, right? So we will need one read function here, so we will need some enablement from basically this one here, some read function here, and like basically this and that. Yeah, so some skeletons, then you copy and paste values from the standard, like register values and stuff, and then you debug, right? Either with the kernel debugger or you good old Linus Torvalds, good old best friend printk. And then like it took me like basically, and then you substitute obviously some stuff from JC43 to underscore to all the other stuff that nobody knows that the best artist steal. And then yeah, you print K and debug through the stuff until you get the values you expect, right? I also, so basically here today before the video, I tested that the spank switching works. So that is here the additional manufacturer information from top secret tables 200 here. Shouldn't show too much. You close your eyes while I work address map. So this is currently 200. I believe 200 hex manufacturer information because I wanted to see that is somewhere you get the idea. And which is also silly that for some standards JEDEC, I mean, this I found so somewhere and stuff. So not only I registered at Renesas, it's super annoying thing, right? I yesterday posted that I didn't get the Renesas documentation. I wonder if Renesas will send me the documentation. I posted the screenshot here on our Discord somewhere. I found this extremely annoying that it was a little bit misleading. I didn't have a Renesas account, at least not that I remembered. And so they have data sheets, which I really hate. This data sheet should be public, but okay, you need to register. Okay, fine. I thought I register and can instantly download it, but no. After I bloody registered, because there was like download register right now, obviously, but then I bloody registered at yet another bloody website, and then when you want to access this probably shortened and probably incomplete datasheet because top secret tables and stuff, and God forbid magic values and register offsets. And then you get your secure access request has been submitted. Please allow time for a review of the request. Responses are typical, provided within 12 to 48 hours. Of course, like 48 hours, I have not yet heard back. In the meantime, but this is also, in my opinion, ridiculous, right? There are not only so many people. I mean, hey, it's some kind of sort of open standard. All I wanted to know were some register offsets and stuff. It's like, yeah, showing you the finger of like, thank you very much that you implement in your free time Linux kernel driver to access all this information and temperature. But here is a finger, even, yeah, whatever. I mean, it's anyway, only DRAM manufacturers need this bloody integrated circuit, and then it's some standard compliant stuff. But even versus the JEDEC stuff here, they want for some standards, they want like $369 freaking dollars, which is even like more expensive than some ISO standards, which I find really ridiculous. I don't want to manufacture. I mean, I really distaste this kind of strange standard organizations. I mean, the DRAM manufacturers or other kind of not only DRAM, also other memory manufacturers get together there. Like, hey, you already get together. Like, why do you need to charge money for people? And it's Samsung, Hynix, and whatnot, and Infineon or whoever still exists in this day and age. And they already sit together on a table and they manufacture this stuff. Like, why do they need to charge $316 for other external people writing open source firmware, early boot code, bootloader, memory tester, like memtest 86, Linux kernel, other microkernel and stuff, and it's like, yeah, I'm not a fan of this. Leave in the comments below. It's ridiculous. So what basically this is kinda, I mean, I get the temperature right, so I could basically stop and I mean, live I cleaned it up a little bit, so we have 40 and 42. It's probably like, obviously, you know, main boards, I have their AIO, NZXT, Kraken Z73 or so, and probably I would expect the module closer to the fan is probably getting a little bit better cooling. But so temperature wise, I get 40, I believe I had 38 last night when it was fresh and I was guru meditating on code. And under full load compiling Firefox for 8 minutes, I believe I didn't even touch 60. And so this is massively overvolted, right? Rated 1.25, and I run them with 1.33 or so, which was the main point. I basically, I don't run Windows, right? I could, otherwise I would have had to boot. Basically the time I would have wasted installing some fresh download of bloody Windows and messing with what other, of course Windows is not reporting it by default anyway, so you would need to have some shareware, personal use, commercial, whatever, software like HWinfo or whatever, or stuff like that, which I also normally don't have because I run my own freaking Linux operating system. So basically the time, you could say the time I would have spent messing with a bloody Windows installation, I invested into writing this kernel driver. So next thing, we could make it more complete. Share, like, subscribe, Patreon and GoFundMe and stuff. Adding here this eeprom support. And last but not least, very theoretically, but there my motivation really stops. I mean, if I would have had 100,000 subscribers already, I would kind of do that, right? Financing open source Linux kernel work here with funny little live streams. Because theoretically we should add this to I2C tools. I believe they probably, all right, don't forget there. Ideally we would want to have tools here to decode that. I believe that's probably what Mozilla or whatever. What's that even kernel? Here's some SCMI2C tools. This is not really what I wanted. Can we also mirror it from? Yeah. It's not the greatest fan of. Can we not have a... Anyway, decoding that, I'm not sure if... I would not expect given that there is currently no driver to read this out, I would currently not expect that to be in there. Could read the man page. DDR, yeah, so eeprom 8024 and EE1004. DDR4, so yeah, most likely. So theoretically we would need to type off here all these top secret tables here from JEDEC specifications into some C code to decode that if we wanted to, but I kinda don't need that really today, so yeah, some more Patreon, GitHub sponsorship. This is all the stuff we could do if we would have some proper fundings, but not only the Linux Foundation is burning 97% previous videos of their money for unrelated farming, water distribution, and who knows what stuff, and the Mozilla Foundation is burning it on Pocket VPN and now AI, so no funding for supporting your components on your motherboard fully. So that's basically that for this video, and maybe theoretically we could continue and make this a little bit more full-featured here in reading the eeprom. The code is basically here. Would need only to export that here and have a loop of switching pages, and yeah, that's for this video. I hope you enjoyed this, learned something. I have this temperature, that is certainly yeah, one small step for me, for my microkernel. A huge step of not having another warranty case, because a year ago a BIOS update burned my previous 5950X memory channel, and certainly a relief to know that the memory is not getting excessively hot. And that's it for this video. I hope you enjoyed this, learned something. As always, leave in the comments below what you want to see more. I can go live again for another 10 minutes or 15 or so, and try to get the eeprom reading into there. Otherwise, have a good day or night, and I hope to see you soon for the next fun and code stuff to come.